Solving the following quadratic equations. Now, this relies on the principle that if a times b equals 0, then either this factor here, a is 0, or that factor there, b, must be 0. So to solve a quadratic equation, you need to make sure you get 0 on one side, either the left-hand side or the right-hand side, and that you've factorised the other side, so you can clearly see each factor, because one of those factors there must be 0. So that's the principle we use for solving a quadratic equation. So looking at this first one, I can see I've got 0 on one side, so that's good. I've got two factors, this one times this one. So I know that one of these brackets here, I'm looking for a value of x, so that when I substitute it into this left-hand side here, one of those brackets is going to equal 0, which of course would give me 0 on the right-hand side when I multiply it. So look what happens when I substitute x equals 3 into this equation here. I'll get 3 plus 1 times 3 minus 3, 4 times 0, which is clearly 0. So substituting x equals 3 into the left-hand side gives me 0. So one possibility, a solution for this equation here, of course, is x equals 3. And the other one you might know is x equals negative 1. Watch what happens when I substitute that. A 0 times, in this case, negative 4, which once again equals 0. So substituting negative 1 into this equation here on the left-hand side will also make that statement true. So the values of x that will make that statement true are x equals negative 1 or x equals 3. Both of those will make the statement true. Right, number 2, I can see I have 0 on one side, I have two factors on the other. So either this factor must be 0 or this bracket, and the values of x that will make that happen are negative 4 or negative 7 would also work. Number 3, substituting 3 into this whole side would give me 3 minus 3 is 0 times 3 take away 5 is negative 2. So that would work. And the other possibility that would work is x equals 5. 5 take away 3 times 5 take away 5, 0 once again. This one here, clearly 6, substituting x equals 6 into this whole quadratic will give me a value of 0. We need to look a wee bit harder at the first factor, trying to think of a value of x that when I substitute it in here, it's going to equal 0. Clearly this would need to equal negative 1. Negative 1 plus 1 would give me 0. So 2 times something needs to give me negative 1. You might know it's negative a half. If you're not sure and you can't work that out, it doesn't take long to write down underneath 2x plus 1 equals 0. That's what I want to solve. Subtracting negative 1, or subtracting 1 from both sides, and dividing both sides by 2 will give you x equals negative a half, and of course the other possibility would be putting x equals 6. Right, number 5, a little bit harder. Trying to think of what value of x I could substitute into this bracket to make this factor 0. This will obviously need to equal negative 5. 3 times something equals negative 5. So if you're not sure, just underneath, write down for yourself a little linear equation this time. Minus 5 from both sides. Dividing both sides by 3 will give you negative 5 over 3. Or, once again, just write down the linear equation while you're thinking. This time we're going to add 1. And dividing by 4 both sides will give me a quarter. Okay, well we certainly have 0 on one side, but our issue this time is we don't actually have factors over here, and until you have factors you can't invoke the rule, this rule here. It relies on you having a factor times a factor. So to do that, we're going to have to make factors, or factorize, in this case the quadratic. And now I clearly have factor times factor. Substituting, x equals 3 or negative 1. Number 7, a 7 and 5. Once again solving, one possibility would be 7 or x equals 5 as well. We're actually saying that when you put one of those values back into this, you should get 0 on the calculator. You could try it. 7 squared minus 12 times 7 plus 35, you should get 0. Similarly, 5 squared minus 12 times 5 plus 35, you'll get 0 once again. Number 8, 9 times 3. Because it's a positive, the bigger number, the bigger one will be the plus. And solving that, we get negative 9 or positive 3. Now number 7, factorising this, actually there's two ways to solve this. It would be just as simple to start by adding 25 to both sides. And then clearly x will be the square root of 25. Now of course there are two answers here, because you're taking the square root, so you need to consider the possibility of 5 or negative 5. So that's one way to solve that one. That will get you the right answer. If you thought about factorising, because it is a quadratic, you would need to recognise that the middle term is missing, that this is in fact a difference of 2 squares, that this is 5 squared, and solving that gives you the two possibilities that we got doing it the other way. Now our issue with number 9 is that we don't actually have 0, so to be able to use this theorem, of course you need 0 on one side. So it would be simpler just to subtract the 4. 4 take away 4, now I have 0. What you do to one side you do to the other, so you need to subtract 4 from that side. Putting it into its factors, making it easier to solve by having factors. I can see that a value of negative 4 or positive 1 should work. So what we're saying is if we take one of those x values, put it back up here, square it and add 3x, we should get a sum of 4. So if I took 1 squared plus 3 times 1, 1 plus 3 times 1 is 3, 3 plus 1 is 4, yes it works. And similarly if we put negative 4 back into the original equation, so negative 4 squared is 16, 3 times negative 4 is negative 12, 16 minus 12 is 4 as well. So both those answers are correct. Number 10, once again, we need 0 on one of the sides, so we'll subtract a 2x and we'll subtract the 8 as well. So I get 0 on this side, x squared minus 2x minus 8. We need to have factors to solve a quadratic. And now we need two solutions from that. One possibility is 4 or negative 2. Once again, we're going to have to do the opposite. To make sure we get 0 on one side. Factorising, 7 times 8 is 56. It's a tricky one. We'll get negative 7 or negative 8. And last one, it's just as easy to square root the 100. Or actually what we're doing is square rooting both sides. The square root of x squared is x. Need to consider of course plus or minus answers, positive or negative answers, so 10 would work, or negative 10.